Good morning, Blue Streaks. It's Monday, April 6th, and we're going to do section 13.2 of our Algebra 2 book. And just wanted to review what we did last week on the first few slides with our Pythagorean theorem and our trig values, our SOHCAHTOA, and then their reciprocals, cosecant, secant, and cotangent. And then we'll talk about some angle rotations today and things like that. So let's get started. On this first one, we have our hypotenuse is 12. One of the legs of our right triangle is 8. And we have to find that third side. So we're going to find that third side by using the Pythagorean theorem. We'll call this side A. So we'll say A squared plus 8 squared, the two legs, equals the hypotenuse squared. So we got A squared plus 64 equals 144. And then we'll subtract that 64 from 144. We'll get A squared equals 80. So then remember, we have to take the square root. Some of you forgot about that when we were doing the stuff last week. So square root, and then that's 16 times 5. We do our factor tree, do it in radical form. Don't use decimals. So that's A equals 4, square root of 16, radical 5. So that's what we got over here. So there's our third side, 4 radical 5. Okay, now, again, what I also like to do here, since I got a 12, an 8, and a 4, 4 goes into all three of those. So I'm going to reduce all of those, divide all of those by 4, so that when I write my fractions, they'll already be in lowest terms. That was another thing some of you didn't do on last week's assignments. Make sure you write these answers as fractions and always put them in lowest terms. So 12 divided by 4 would be 3, and 8 divided by 4 would be 2, and 4 divided by 4 would be 1, so it's just radical 5. So there's my hypotenuse of 3, opposite side is 2, and adjacent side is the square root of 5, because there's my theta. All right, so then I'll do my 6 trig functions, okay? So I'm just going to use S for sine. So sine of theta is opposite 2 over hypotenuse 3. And remember, cosecant, CSC, is the reciprocal of that. So that's 3 over 2. Now we're supposed to find all 6. Some of you didn't do that on the worksheet from 13.1. So cosine would be adjacent, square root of 5, over hypotenuse 3. And then secant, which we use SEC, is the reciprocal of that. So that's 3 over the square root of 5, but we have to rationalize our denominator. Multiply by radical 5 over radical 5. So the top becomes 3 radical 5, and the bottom is 5. And the last two are tangent of theta. Oops. I'm just going to write it all out. Don't need to. All right, opposite 2 over adjacent radical 5. And I have to rationalize that. So when I do that, I multiply the top, oops, use my 2 first, radical 5. And then the bottom becomes a 5. And the cotangent of theta would be reciprocal of that. Just do this one here, the original. So then you just have square root of 5 adjacent over opposite 2. So there's our 6 answers. That's just a review from section 13.1, intro to trigonometry, SOHCAHTOA stuff. Okay, here we got a 45, 45, 90. Okay. Now remember that this is the one that we wanted to, and it says use a trig function to find it, so we could do it that way. You know, here's our 45, we could say, and there's our hypotenuse, and that's the opposite. So we could say sine of 45 equals x over 60, and then solve for x, but I don't like it to do it that way. Excuse me. I like just to have this memorized. I know that these two sides are equal, so this we could say is x. And this hypotenuse is always the short or the leg times the square root of 2. Okay? So if I go from here to here, I get multiplied by the square root of 2. So if I go for the hypotenuse to the leg, I divide by the square root of 2. So the x is 60 divided by the square root of 2. And then rationalize it. I always like to put it in simplest radical form, except for the word problems. Then we can use decimals. So we get 60 times the square root of 2. Sorry, it's so sloppy. Over 2. And then that's 60 divided by 2. It's a bad 0. That 60 divided by 2 would give me 30 times the square root of 2 would be our answer. Okay, so that's how I like to do it. And I have it in radical form as well. Okay, for this one, we need to draw a right triangle. All right, so here's a right triangle. Okay. And I'm going to say plane. Oops, I need my P for plane and H for helicopter. Remember, that's a right angle here. That's 90 degrees. Okay. And it says the angle of depression. Oh, okay. It's 12,000 feet here. Where the plane is, and it's 4,500 here. That's just the height. Oops, sorry, wrong spot. So I'm going to subtract those. 12,000 minus 4,500 will give me this distance. The difference in their two altitudes, their two heights, which would be 7,500. So this side, that leg of the right triangle, is 7,500 feet. All right, and then it says the angle of depression. Okay, angle of depression from the plane to the helicopter is this angle out here. Okay, so a lot of kids will put it inside the triangle there. It's actually outside the triangle. But this one down here, the angle of elevation from the helicopter to the plane is inside the triangle, and they're always equal. So I always put it down here inside my triangle when I have a problem like this. So that's 27.6 degrees. That goes there. All right, it says, what is the distance between the two to the nearest 100 feet? Okay, so usually when we do distance, we do it, you know, like we were on the ground. Okay, so we could make that x. All right, if we're thinking, you know, straight from the plane to the helicopter, we could use the hypotenuse. So it depends how you think about it. It's hard here, but usually when we're looking for distances between objects, it's the horizontal distance this way. So I'm going to make it x here. Okay, so I have this angle, 27.6. I got this side opposite and this side adjacent. So to solve this, opposite over adjacent, TOA, I would use tangent. So tangent of 27.6 equals opposite 7,500 over adjacent x. So again, I like to make it a proportion, and then you just cross multiply. So it's x times the tangent of 27.6 equals 1 times 7,500, which is 7,500. And then divide by the tangent of 27.6 to solve for x. Remember, put tangent. Okay, remember to make sure you're in degree mode. So I'll get my calculator out and do it. Again, hit mode, make sure it's in degree. It is. So 7,500 divided by tangent, it's right there, of 27.6. Close it up. So we get 14,346 feet. Oops, let's undo that. Okay, so it looks like the answer there, the book was doing, they were going to use this as the distance. Okay, so again, that's kind of worded weird. When we actually have a quiz on this, you'll be able to understand what to do there. Okay, so I did it thinking this was the distance between the two. They wanted the hypotenuse. So then we would have done sine instead. Sine of 27.6 equals 7,500 over x. They would have put the x there. Okay. Those were answers from the last homework assignment. We already went over that. I'm not sure what that goes to, so we'll just not worry about it. All right, and we're moving on to today's lesson. All right, so we're going to draw angles in standard position, determine the values of trig functions for an angle in standard position. So we're going to draw triangles, basically. So standard position, initial side, we'll talk about terminal side, angle of rotation, coterminal angles, and reference angles. All right, so we talked about 13.1 trig functions, and then it says an angle is in standard position when the vertex is at the origin and one ray is on the positive x-axis. That's our initial side. And the other ray is called the terminal side. That's the one that will rotate. In the next slide, you'll see this picture. Okay, so always from the origin to the right along the x-axis, that blue side is our initial side. See it on both pictures. And the red one we call the terminal side, and it rotates. Okay, and a counterclockwise this way, that's positive degrees. And if we go clockwise this way, sorry about that, that's negative rotation, measure of angles, okay? So as you go up, there's your 90 degrees, and then halfway is 180, and then 3/4 is 270, and all the way around is 360 degrees. If we're going, in the negative rotation direction, we're going, right there's negative 90, negative 180, negative 270, and then negative 360 all the way around. Okay, so that's the directions we'll do. And again, this is an angle in standard position, always starting our initial side right there on the x-axis and then rotating around. Okay, so an angle of rotation is formed by rotating the terminal side, that's the red one. Well, they're both red this time. We started our initial side, and then we rotate around, and it'll stop somewhere. If the terminal side is rotated counterclockwise, it's positive, and if it's clockwise, it's negative. And you can go more than 360 degrees. Like this picture is 390 degrees because it went around. So when it got to there, that's 360, and then it went past a little bit more, actually 30 degrees more, and that's a picture of a 390 degree angle in standard position. Okay, again, a complete rotation is 360 degrees and 180 is halfway around. Okay, so if we want to draw an angle in standard position here, all right, we always start on our initial side right there, and then we're going 45 degrees. That's positive, so we're going this way, and that would just be up here. We draw an angle, a little rotation there, little arrow, and then just label it, 45. Inside or outside, it doesn't matter. Okay, this one is negative 135, so we start here again. And then we're going to go this way, counterclockwise. Remember, that's 90, so we're going to go past 90 to about there, and then draw our terminal side, and then that's our negative 135. 210. Let's move this up a little bit. 210 positive, so we go 90, 180, a little bit past 180. Draw there. Again, there was our initial side, sorry. There's our terminal side. So we rotate it around, and then we just write 210. So label them so you can tell how many degrees. Remember, 90, 180, 270, all the way around 360. And that was positive again. The middle one was negative the other way. All right, so here's another one, 210. We just did that one, didn't we? Yeah, so we won't do that again. All right, 385. So here's our initial side. All right, now remember, we go all the way around, and that's 360. So we're going to go past a little bit by about 25. So there's my arrow. And then draw your terminal side, and then there's your 385. Okay, and then for this one, again, our initial side's always there. This is negative, so we go negative 90, negative 180, negative 270. So we're going to go a little bit past negative 270. And that would be negative 300. So that's how you draw an angle in standard position. Pretty easy to do. Hopefully you understand that. Okay, coterminal angles are angles in standard position with the same terminal side. For example, angles measuring 120 degrees and negative 240 are coterminal because that terminal side stopped in the same place. All right, it says there are infinitely many coterminal angles. One way to find the measure of an angle that is coterminal with an angle theta is to add or subtract integer multiples of 360. So basically all we're going to do is add and subtract 360. Okay, so if we do the blue arc, the positive measure, we go 90 and a little bit past to get to 120. If we do the negative, we go 90, negative 180, and go past about 60 degrees, and we'll stop in the same spot. So positive 120 and negative 240 are what we call coterminal angles. Okay, so all we got to do here to find a positive and a negative is just add 360 and subtract 360. And 360 plus 65 would be 425. And then 65 minus 360. So make sure I do this right. 65 minus 360. So that's negative 295. So there's two angles coterminal with 65, one positive and one negative. Okay, now this one's over 360. Okay, so what I do when in that situation, I'm just going to subtract 360 twice. Okay, so when I subtract 360 from 410, I get 50. So there's my positive, and then I'll just take that 50 and subtract 360 again. Or you could subtract 410 minus 720. That's the same thing. So 50 minus 360 should be negative 310. So there's a positive and a negative angle coterminal with 410 degrees. For 88, we're going to do the same thing. Plus and minus 360. You guys can do that on your own to get those two answers. All right, reference angles. For an angle theta in standard position, a reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Okay, so this one, theta was a positive number, right? And it rotated here. That looks like it's about 120 degrees, just guessing. That reference angle is between the terminal side, see, terminal side, and the x-axis. So this red arc is what we're looking for the reference angle, okay? It's always back here by the origin between the x-axis, either the negative x-axis or the positive, depending where you're at, and that terminal side where it stopped. It's always an acute angle, all right? So it's less than 90 degrees in there. So it could be in here in the first quadrant. It's going to be between 0 and 90. In the second quadrant, between 0 and 90, but we're going to go 180 minus this answer, this angle, to get that. If we're in the third quadrant, we're going to take however many degrees it is, let's say it's 200, and go back towards the x-axis. So 200 minus 180, that would give us a 20-degree reference angle if we're in the third quadrant. In the fourth quadrant, we would go all the way around is 360. You know, there's our x-axis. So if we draw a line out here, it's between that terminal side and the x-axis. So it'll be over here. So we go 360 minus that. So say it was 300 degrees, we'd stop in here somewhere, and we'd go 360 minus 300. Our reference angle would be 60. So let's look at a couple examples. All right, so I draw that real quick. Here's my y-axis, my x-axis. 135 degrees starts here and stops over here somewhere. All right, so that's 135 from there to there. My reference angle is this angle between here and there. So you go 180, because remember, from there to there, halfway is 180 minus 135. And you get 45. So the reference angle would be 45. It's always positive, always less than 90, okay? If we draw this one, okay, again, we're going to start, well, I start here, then we go this way. So remember, 90 would be to there, so 105 would be a little bit more, okay? So that's 105. We still go 180 minus 105. And then we'll still get that positive number, which would be what, 75. So the reference angle right here would be 75. Okay? At 45 would have been right there. Okay, sorry I'm sloppy. I'm not very good at this with my mouse. Okay, here's another one. Okay, remember, you know, here's our y-axis going right through there. There's our x-axis. So we went around 325. Here's our reference angle right there. So all the way around, remember, is 360. So we're going to go 360 minus 325. Oops, not 225, but 325. And what is that, 35? It's a bad 5, sorry. Ooh, now it looks like a 6. minus 325 equals 35. That's better. Again, less than 90, positive. All right. Again, you can do that on these as well. Shouldn't be a problem for you. Okay, just again, that's past 90, so you go 180 minus 105 for that one. Another one past 90, so 180 minus 115. Both of those would be in the second quadrant. All right, the next type of problem is they're going to give you a point in one of the four quadrants. Remember, first, second, third, fourth quadrant. So they're going to give us a point. We know how to plot points. And then what we're going to do is we're going to draw a triangle from that point. We're going to draw a line straight back to the origin, straight down to the x-axis, and make a right angle. And then whatever that x value is will be here. Whatever that y value is there will be there. And we'll use Pythagorean theorem to find the hypotenuse, which they're going to call r now. For if you think about this as a circle, that would be the radius from the center of the circle out to the edge there. So it's, this squared plus this squared equals r squared, which is the square root of x. So that's where this came from. Okay, so let's look at an example. Oh, also, when it's drawn in this picture, okay, you got your y value, theta will always be inside the triangle back by the origin. All right, so that's a reference point. So when theta is always here by the origin, the opposite side will always be this y value. And the adjacent side will always be this x value, and the hypotenuse will always be the r. And the r is always positive, okay, but the x value and the y value, I don't know why they put absolute values. They could be positive or negative, depending where the picture of our triangle is, okay? So sine opposite y over hypotenuse r, okay? So if you look at this next slide, that's where the y came from, and that's where the r came from. Just like opposite and hypotenuse, it did not change. They're just using letters now instead of the words, okay? For cosine of theta, again, theta is there. That's our reference point. Cosine is adjacent x value over hypotenuse r value. So that's where that x and that r came from. And then tangent, okay, again, opposite over adjacent, TOA, y over x. See, y over x. Okay, so what I like to remind kids of, we have the point xy, and then we have our r, right? It's the hypotenuse, always positive. Okay, if we go alphabetically, okay, cosine in the alphabet would come before sine, right? Cosine C, sine S. So the cosine has the x on top because x becomes before y. Cosine comes before sine, x comes before y. So it's x over r for cosine, and for sine, y over r. Just think about the alphabet, then you know which one is over r for sine and cosine. All right, so here's an example. All right, they give us the point -6, 9. So if we come over here, 6 and up 9, I think that's where our point would be. Let me make sure. 1, 2, 3, 4, 5. Yeah. Okay, so there's that point right there. All right, so we're going to draw our triangle from that point. Okay, so it's not going to be very good straight lines, but that's going to be there for our hypotenuse. And then we're going to go straight down to the x-axis, and then we go straight over. So there's our triangle, okay? And we know the values of the sides. This is a -6 because my x value is -6. And this is +9 for my y value. And then r is down here. A squared plus b squared equals c squared, which then you take the square root, and then they simplified it. This was 9 times 13. If we do the factor tree, so the square root of 9 gives me that 13, I'm sorry, that 3 in front of the radical 13. All right, now again, there's my 2 legs and my hypotenuse. Remember, back here by the origin is always theta. That's our reference spot. Also, though, as you can see, we got a 3, a 6, and a 9. 3 goes into all 3 of those. So we're going to have to reduce our fractions. So I like to do that in the beginning. So I'm going to make 3 divided by 3 a 1. And -6 divided by 3 would be -2. And 9 divided by 3 would be 3. So those are the numbers I'm going to use to find all 6 trig functions. Okay? So again, it's hard to see. Well, there's a theta that I was going to use. So it doesn't look so sloppy. It's right in there. Let's do this. Okay. So there's theta. Looks better than mine. All right, so then we're just going to go, our sine, cosine, tangent, cosecant, secant, and cotangent. So sine would be opposite 3 over hypotenuse 1 radical 3, or y over r. Okay, so it's the same as what we did in 13.1 now. Okay, I'm not going to write them all out because I'm taking too much time already. And then our cosine would be -2 over hypotenuse radical 13. And then again, rationalize the denominator. Make sure you simplify those. And again, it's negative for that one. And then tangent would be opposite 3 over adjacent -2. And then for cosecant, I'm sorry, secant, yeah, cosecant goes with sine. It'd be hypotenuse, radical 13, over opposite 3. Just flip your sign. For secant, it's reciprocal of cosine, so it would be hypotenuse, radical 13, over -2. And cotangent's the reciprocal of tangent, so that would be adjacent, -2, over opposite 3. So you'd have 6 fractions there. Make sure it's fractions and in simplest radical form. We don't want decimals for these answers. Oh, here they are right here. Okay. They reduced them all. That's sine, cosine, and tangent. And then the next slide will be the other 3. All right, so they're written out on those second 2. All right, because r is a distance, it's always positive. So no matter if x and y are negative or positive, that's okay. R, always, always, always positive. Always remember that. Okay, so here's another one. It's in the second quadrant again, -3, 6. I'm just going to draw it bigger and then label the sides for you. Let's make it look a little bit nicer. All right, so negative, I'm just going to go like this. Move it down. Oops, or just move that up. There we go. So there's our right triangle. Okay, we'll label it. The x is -3, and the y is 6. There's our right angle, always on the x-axis. And theta, do I have another theta there? No, but theta would be right there. And we'd have to find the hypotenuse. So we'd go a squared, -3 squared, plus b squared, 6 squared, equals c squared, or our r squared. Remember, that's our r. Okay, so that's a positive 9. That's always going to be a positive number when I square it, and that's 36. So that's 45. Remember, that's r squared, so I have to do the square root of that. Don't forget to take the square root. So that's 9 times 5, right? So the square root of 9 is 3. 3 radical 5 would be this side. Again, 3's go into all 3 of those numbers, so I'm going to reduce them. Make it easier on yourself. So 3 divided by 3 is a 1, negative 3 divided by 3, negative 1, and 6 divided by 3 would be 2. And then I'd find, again, they're talking or wanting exact value, all 6. Okay, so sine is opposite 2 over adjacent radical 5. And then rationalize it. I'm not going to do that to save time. The cosecant would be negative. No, it's not negative, sorry. It's radical 5 over 2. It's not a negative, not a sign, that's just a radical. Okay? Cosine is negative 1 over radical 5 adjacent over hypotenuse, x over r. And then rationalize it, and then secant, it's SEC, be radical 5 over negative 1. And then tangent would be opposite 2 over adjacent negative 1, or y over x. So 2 over negative 1. And the cotangent, COT, would be the reciprocal of that, negative 1 over 2. So there's our 6 answers. Again, rationalize your denominators there, simplify lowest terms all the time. So that's how you do those. They'll give you a point. Okay, they gave most our examples were in the second quadrant, but they could be the first, third, or fourth quadrant as well. Okay, just remember your signs. If you're in the third quadrant, x and y are negative. Remember, r, hypotenuse, is always positive. In the fourth quadrant, x is positive, y is negative. Okay, so you're going to get some negative answers. That's okay. All right, and I don't know, they got the answers there. Yeah, looks like they got the answers there for you. Got to reduce those. All right, I'll click that. All right, there's the reduced answers down there, which we did. And then the reciprocals. Okay, so that's basically it. You can do those for extra practice if you want. But here's your assignment. Again, do the best you can. This will be due Tuesday, the 7th of April. I hope you guys are staying safe and healthy and getting outside to exercise a little bit and getting your schoolwork done. Again, don't hesitate to email me or get on my conferences. Today, Monday, I won't be able to have conferences with you because my mother-in-law passed away and we're having a funeral today. So, but email me if you have questions tomorrow morning from 8 to 8:30. I have conference time as well that we could get on and do some face-to-face problems if you'd want. But you guys have done a good job so far. I appreciate you turning your stuff in and getting back to me. Again, I hope you guys are doing well and keep up the good work and have a great day. We'll talk to you later.